On the morning of August 26, 2026, a devastating surge came rushing through the narrow Himalayan valleys along the Nepal-Tibet border. What followed was a fast-moving mass of muddy water, rocks, ice, trees, and debris, overwhelming communities located along the river corridor. Videos recorded during the event show the river rising with extraordinary speed. Within moments, the flow overtook roads, bridges, buildings, vehicles, and other infrastructure in its path. The surge moved downstream through the Trishuli river systems, affecting communities far beyond the area where the disaster first began. In some places, buildings were swept away. In others, homes and businesses were left buried beneath thick layers of mud and sediment. Roads were cut off, bridges were destroyed, and sections of the river corridor were completely reshaped. As we watch these videos, one thing is immediately clear. This was not just an ordinary river flood. So let's slow this down and look carefully at what we know so far. In light of some of the early assumptions and reports about this disaster, let's first look at what happened high in the mountains. These satellite images from August 25th and August 26th show a massive section of glacier ice and rock breaking away from the slope. This collapse appears to be where the entire chain of events started. So with that in mind, it is fair to say this was not a typical rainfall-driven flash flood. The flooding downstream was sudden, but the event itself began with a massive collapse of glacier ice and rock high in the mountains. Second, this was not triggered by an earthquake. A strong seismic signal was recorded during the event, so it was initially reported as an earthquake. But after analyzing nearby seismic stations and satellite imagery, the United States Geological Survey determined that no tectonic earthquake had occurred. The signal was produced by the enormous mass of ice and rock crashing down the mountain. It released seismic energy equivalent to a magnitude 5.2 earthquake. So the collapse caused the shaking, not the other way around. And third, this is not a confirmed GLOF. So far, no pre-existing glacial lake has been confirmed as the source of the floodwater. So, basically, it is fair to say that a massive rock and ice avalanche came down the mountain and entered the river system. But what happened after that is still uncertain. And it all comes down to two possible scenarios that could explain the massive surge observed downstream. A massive volume of glacier ice and rock races down the mountain, possibly at more than 100 miles per hour. When it reaches the valley floor, it shatters, mixes with meltwater and the water already flowing through the channel, and keeps moving. Along the way, it picks up loose sediment, boulders, trees, and even more water. The flow becomes bigger, heavier, and more destructive. This process is known as bulking. So what begins as a rock and ice avalanche quickly transforms into a high-energy debris flow, and then into a heavily debris-laden flood farther downstream. In this scenario, there is no lake outburst and no dam breach. The collapse itself generates the initial surge, and the flow continues growing as it moves through the river system. The latest United States Geological Survey assessment also describes a similar process. But here is the big question. Could this process alone explain the massive volume of water and debris observed downstream? Or did something else happen in the valley? That brings us to the second scenario. In this case, the rock and ice avalanche enters a narrow section of the valley and temporarily blocks the river. Water begins building up behind this unstable mass of ice, rock, and debris, creating a short-lived natural dam. The blockage may have lasted only a short time, but in a steep mountain river, even that could be enough to hold back a significant volume of water. Eventually, the water overtops the blockage, or the debris dam begins to erode. Once that happens, the blockage could fail very quickly. The stored water is suddenly released, picking up even more sediment and debris as it rushes downstream. This creates a sharper and potentially much larger flood wave. Under this scenario, the initial avalanche still creates a debris flow, but the temporary blockage and breach amplify the surge that follows. ICIMOD is also investigating this possibility. Its preliminary assessment suggests that the ice and rock debris may have temporarily blocked the river and released a sudden surge downstream. but this has not yet been confirmed. The exact location, size, and duration of any blockage are still uncertain. But this scenario could help explain the sudden and massive rise observed far downstream. So, which of these two scenarios actually happened? At this point, we simply do not have enough evidence to say for certain. The most realistic explanation may be a combination of both: an immediate debris flow, followed by a temporary blockage and breach. As more evidence becomes available, we should get a clearer picture of what happened in this valley. Until then, this is a developing investigation. Let me know what you think of this massive flood.